Welcome to day 2 of your chromatography lab. On day 1, you did high pressure liquid chromatography. And so for part 2, I want you to make your observations. Open up your high pressure liquid chromatography lab and make your observations about the solute left behind once the effluent was evaporated. These are our community dishes, and you'll notice some residue of probably a salt left behind here. This could be the maltodextrin. This could be our red food coloring. Here's our blue food coloring. And these should be our flavoring oils that came through last. And so make your observations. See if you can get a smell out of this one. Now, to begin your paper chromatography, don't touch the paper. Your hands have oils in them, and the oils will change the retention factor of the paper. And we want to control for that in all cases. And so use your forceps. And if possible, whenever you set your paper down, set it down on clean paper so you don't contaminate your paper. Keep the paper clean, don't touch the paper. You have a 0.1% solution of sodium chloride in your beaker, and it's reusable for all the periods, so don't pour this out. If you don't have enough in your beaker by the time you get to it, just call us over and we'll reload your beaker. Here's your paper, and notice I'm holding it with my tweezers so I don't contaminate it with my oils from my finger. And all right, so your paper is going to have a line on the bottom of it, and that line should be about 1 centimeter to 1.5 centimeters from the edge of the paper. That's why you have rulers at your desk. But what's important here is to make sure that when you submerge your paper into the salt, that line is above the solution. You don't want your dyes to dissolve in the solution. You want them to dissolve in the paper as the solution passes through the paper via capillary action. All right, so we've got these butterfly clips, and you can clip your paper to the butterfly clip and then compare the line at the bottom of your paper with the top of your solution. And make sure that that line, when you submerge it, is at least 0.5 centimeter above the solution so that your dye doesn't dissolve in the solution. All right? The line should be at least 0.5 centimeter above the top of the solution. Once you've confirmed that that line is above the solution, I want you to bring this over. So just slide the pencil. It's a really safe way to carry your paper. Bring this over to the dyes. I'm carrying my paper around with my lab so that I can set my paper, my chromatography paper, on my lab so it doesn't get contaminated by anything that I set it on, and I'm continuing not to touch it with my hands so I don't contaminate it with the oils. You and your partner are going to be assigned 2 known food dyes, and then you'll be assigned an unknown. So the known food dyes are red number 3, red 40, green 3, blue 1, yellow 5, and we have mystery mixture A and mystery mixture B. So I was assigned red 3. There's a capillary tube in the beaker, and you want to keep your finger on the top of that capillary tube, bring it over to your line and over toward the edge, touch it 1 time, and then put your capillary tube back. And I'm going to do yellow number 5 as well on the other side. Keep your finger on the top of that capillary tube, don't let go. It will reduce the amount of dye that makes it onto your paper. And just touch it 1 time and then put your capillary tube back. Now in between, adding more dye to this paper, I want you to bring it over to these heat lamps. I have a heat lamp set up. The two on the left are just infrared, so they don't have any visible light. And they're a little warmer than the one on the right, but it does give us some room for multiple papers drying at once. Leave your sample under the heat lamp until the solvent or the water that the dye was in is evaporated. And flip it over a couple times. It dries pretty quickly under these heat lamps. And then return it for more dye. You can do that 3 times. Return it to the dye and put more dye in the same exact spot. To put more dye in the same exact spot, follow the same procedure. Put your finger over the capillary tube, bring it back, and just one little touch, and then put it back. Grab your other color, and one little touch, and then put it back, and as swiftly as possible bring it back to the heat lamp for drying. Back here at your lab station, put your pencil back in your butterfly clip and set that on your beaker, and just the bottom of your paper should touch the salt. Remember, the salt level should not reach up and touch your dyes. Notice I'm very, very close, but I'm still happy with my heights. And you're watching that solvent rise on the paper. As the solvent rises on the paper, you can work on the questions from the first day of the high pressure liquid chromatography lab and try to stay efficient, because like right now you've got some downtime. Unless you want to use your other beaker to do your unknown. I'm going to assign you 2 known colors and 1 unknown, and from collective data, you're going to determine the dyes in your unknown by matching the retention factors, or your R sub F. Keep an eye on that solvent front, and you want to stop when the solvent front is almost to the top of the paper. If you let it get to the top of the paper, your RF number means diddly squat. So stop it here below the butterfly clip top. Well, I've run out of time to let that solvent front go all the way to within about a half centimeter from the top of the paper. That would be ideal. But let me show you what to do once you're all done. So let's say the solvent front is a little closer to the top of the paper. We'll get a better RF value the greater the distance that solvent front travels. And so pull it out, grab that pencil, and start making marks on this thing. You want to mark your solvent front. You've got your beginning line. The distance here is your, that's your denominator. You want to put a really light circle around what you see for your dyes. There we go. And you want this distance and this distance. You're going to take an average of those distances to here. Of course, this distance, and it's hard to say. We're just going to use 0. And an average of those 2 distances, and that distance and 0, of course, divided by the distance from here to the end of your solvent front. And the mathematics there I'll include right here. Go ahead and take a picture of this image. You need the top edge and the bottom edge of your dye zone, and you can see down here at the bottom it's an average of those 2 differences over the distance that the solvent front traveled. that's going to get you your retention factor or your R sub F. And that should be really indicative and unique for your dye. Go ahead and do the same thing for your unknown that's been assigned to you, and collect data from everybody. And we'll talk tomorrow about what you need for the lab report. Thank you. Good luck.